Okay, the next section is basically a review from the previous course. 2.6. I like to call it Algebra of Functions. And function composition. Tell me if this is better or not. Is it? Okay. Algebra of functions and function composition. Well, when we talk about algebra, we talk about adding, subtracting, multiplying, and dividing. And also, I forgot to mention that the lowest test grade will be replaced by the final exam grade. I always do that. You don't have to remind me. So if a student gets an 80% on the final exam and the lowest test grade is 70%, I replace the 70 by 80. Just one test. So everyone can still get an A in the class, depending on how much effort you put in this.
How many questions?
Enough to keep you busy for 2 hours.
So if we found the five did great on the first test.
I will not replace anything. And you cannot do that to me. Algebra functions, we are talking about addition, subtraction, multiplication, and division of functions. That's what algebra is all about, right? So if I ask you to create a function given f and g, these are given to us, two functions. If I ask you to find or create the function f plus g of x, this is the name of the function I want you to create. So what will you do? Oh, of course, f of x plus g of x by definition. So if I ask you to subtract them, what will you do? Oh, of course. That's very clear, self-explanatory. What about fg of x? What will you do to f and g to create the function fg of x? Very good. Multiply. And the last one here so far, what would you say about this? How will I write it? Very good. However, I have to put a comma, and I have to write if. I didn't put a comma and wrote if for number 1, 2, 3. But I have to write a comma and put if for number 4.
It has to be greater than 0.
Careful.
Can be equal to 0.
Awesome. Thank you. G of x cannot equal 0. It can be greater, it can be less, but it cannot be 0. Any questions? Now, here's a problem. Let's suppose I should say potential problem. Let's suppose I have two graphs. Here is a graph between 1 and 5. And this is the function f. Does this represent the function? By the vertical line test, this is a function. Very good. Now here's another question. Let's suppose I have function g, let's say between 6 and 10, and here's the graph of function g. And let's suppose I want to create a sum. I want to create a new function that is f plus g of x. And you will say, I know. You will say, very good. So now, having this definition, I'm going to ask you to find f plus g of 3. Before you look at the graphs, don't look at the graphs just yet, I'm going to ask you, if x is 3, what would you tell me to write?
F of 3 plus g.
Obviously, f of 3 plus g of 3. Now look at these two functions and say, oops, and explain why I said whoops.
So one doesn't include
Exactly. Which function is undefined at 3?
G.
So bottom line is, I cannot create this function. It means nothing. There is not one single x value that I can plug in it. So conclusion then, in order to find the sum, difference, product, and ratio of two functions, what has to happen? They have to have a
Common point,
common,
exit point,
I need the word, common,
integer.
common, excellent, thank you. If they don't have a common domain, the function is useless. I cannot create the sum, difference, product ratio. So common domain is the key. If there is no common domain, there is no sum. There is no difference. There is no product. There is no ratio. Do we understand this? Because there is not one single value that we can plug in to get an output. Is this clear to everyone? Yes? So common domain is the key when adding, subtracting, multiplying, and dividing functions. So the common domain is the key when we add, subtract, multiply, and divide functions. So there are 4 different ways, right? 4 different ways to create a new function by adding 2 functions, subtracting, multiplying, and dividing. So let's look at an example. On page 310, on page 310, now I'm really going exactly within the limits here. So please choose a problem. Not an odd number problem because it has the answer in the back. Please choose an even number problem so we can work on it. So you can, which one?
6.
6 it is. Thank you, Tim. So we have f of x equals x squared plus x minus 12. In this case, we're only asked to find the domain. So this is problem 6 on page 310. Can anyone identify this function correctly for us so we know what it is? Perfect. What is the domain of a quadratic function?
Infinity, negative infinity.
That's it. It's a polynomial function. There is no restriction on x squared plus x minus 12. Okay. I still would like to look at 27 was recommended. I'm going to look at 28. G of x equals the square root of x minus 3 divided by x minus 6. Let's look at this function and identify what it is. Can anyone tell us what do we do to create this function? No, we cannot do anything. This is a function. This is the name of a function. We cannot touch it. We're asked to find, sorry, you're right. I didn't say what we're trying to do. Of course, we are trying to find the domain. I shouldn't say of course. It wasn't clear. We're asked to find the domain. Sorry. Good. I can't touch it. First of all, I have to answer the question, how was it created?
Dividing 2 functions.
Awesome. So it's a ratio of 2 functions. Good. So then we just talked about the common domain. If these two, or this function g is created by the ratio of 2 functions, then what am I looking for? Common domain of these 2 functions. But also I have to remember that it's a ratio. Okay. What is the domain of the bottom, x minus 6? Forget about the fact that it's part of a ratio right now. What is the domain of x minus 6? It's a polynomial function. X minus 6 has no restrictions. All real numbers, correct? Okay, forget about that part for a second. Look at the top. How do I find the domain of the top? Careful. Say it again. All. So you have to give me something that I have to solve to show everyone what I'm doing. Do not solve anything. Just tell me what to write, and then we'll solve it together. Yes, x minus 3. Let's
Cannot
think.
equal
Yes, cannot equal.
0.
Why not? The square root of 0 is 0.
Negative.
Right, it cannot be negative. So how do I write that?
3.
Cannot equal sine 0.
Greater than or equal to 0.
Thank you. I have no idea why this radical, poor radical, creates such a big tragedy. Can we write it down somewhere? How do I find the domain of a square root? I have to take the quantity under the square root and make it greater than or equal to 0 and solve the inequality. Can we do that? Write it on every page for the next 10 pages. We have to remember that, right? That's the condition for the top. The bottom has no condition because it's x minus 6. However, because it's a ratio, there is an additional restriction that I have to write. Not just this. There is one more.
X cannot equal 6.
Awesome. Only because x minus 6, otherwise it would have been all real numbers. But x minus 6 is in the denominator. Awesome. So I have to solve the first inequality. So x is greater than or equal to 3. And the second one is not equal to 6. Let's say I don't see what the domain is. And let's graph everything on the real line or number line. Greater than or equal to 3 is this. Not equal to 6 is this. Not 6. So I have to put everything together. Both functions have to exist at the same time. And that if x cannot be 6. Can anyone give us the domain of this function now? Function g. Not the top, not the bottom. The whole thing.
Brackets 3.
Say it again.
Brackets.
Awesome. Was awesome. Very good.
6.
Perfect. You understand how many concepts we talked about? We talked about the concept of finding the domain of a square root. We talked about the concept of not having 0 in the denominator. And we also talked about the concept of making sure that both functions have a common domain for the entire function to exist. Is that clear? Yes? Questions? Okay. Yeah. Any preference?
No.
Okay, so 27 was recommended. I can make one up.
This one.
Okay. Or just this one. Whatever. You can make one up. Okay. The same question. We are asked to find the domain of this function. Okay, what do I have to write? Please, for me, write down somewhere, and no, not on the back of your hand, Tim. How do I find the domain of a square root? The answer is the quantity under the square root has to be greater than or equal to 0. Assuming the radical is not in the denominator, though, because then it has to be greater than but not equal to, right? So how do I find the domain of a square root? I take, assuming it's not in the denominator, I take the quantity under the square root and make it greater than or equal to 0, and I solve the inequality. And that gives me the domain of a radical function. Is that okay? Okay. So what restrictions will you give me, please? Yes, indeed. Perfect. So in that case, I have x greater equal to 2, and here I have x not equal 5. If it's difficult to see, which it's possible, it's okay, just graph it. Here is 0, here is 2, and I am told not 5. Here's 5, not 5. So what will be the domain of this function then? Yes? Domain of this function g, bracket, 2, comma, oops, 5, yes, 5 to infinity. So this in plain English says everything greater than or equal to 2 except 5. Good, moving on. So let's pick two functions. I've never done this, just to stay within and not, but let's do it, just to make sure that 31 through 49, 50, 53, 55. Okay, 49. 41 through 49, please choose.
42.
42. So we want to look at 42. That gives us two functions. Let's copy them. You said 42. Very good. So we have f of x equals 6 minus 1 over x, and g of x equals 1 over x. Nice. Good pick. So the problem is asking us to find f plus g. They're asking us to find f minus g, fg, and f over g. They're also asking us to find the domain of each. I want to mention one thing before we come back here. I'll come right back. I just want to mention something, and I want to write it down. Common domain is also and always the domain of three functions: f plus g, f minus g, and fg. Let's take a moment and summarize this one more time. Once I have the common domain and I establish the common domain, I don't have to write the domain of these three again, because it's the common domain. And you notice here I did not look at or talk about the ratio. I have no idea what happens with the ratio because of that if. I don't know. But here, once I find the common domain of f and g, that is for sure the domain of the sum, difference, and product. Always. But it may or may not be the domain of the ratio. So coming back here, I want to start with that. What is the domain of function f? And then I would like the domain of function g. And then I want the common domain. So what is the domain of function f?
Negative infinity.
Okay, I have to make myself a note. For the next 10 pages, I have to write it down. How do I find the domain of a ratio or a rational function? How do I find the domain of a rational function? I make sure I can divide by negative numbers.
Which is in zero.
Say it again.
Which is in zero.
Exactly. So it can be positive or negative. This is not a radical. Radical requires greater than or equal to 0. Rational requires denominator not 0. Are you with me?
Yeah.
Okay. So then what is the domain of this function?
Negative infinity, comma, 0, parenthesis, union, parenthesis, 0, comma, infinity.
That's it. What is the domain of G? Same thing. What is the common domain?
Negative infinity, outside 0.
Exactly. So negative infinity 0, union 0, infinity, negative infinity 0, union 0, infinity. So the common domain, CD, will be negative infinity 0, union 0, infinity. For that reason, although I do not have the sum, difference, and ratio, can anyone tell us the domain of the sum, difference, and not ratio, forgive me, the sum, difference, and product? What is the domain? I don't have the functions yet, but I already know their domain. What is it? Exactly, the common domain. Union 0, infinity. Any questions so far? Okay, coming back to f plus g. We must write the definition first. So f of x plus g of x. I have to write that. And then carefully identify and replace. What will you dictate? 6 minus 1 over x plus 1 over x. What is the answer?
6.
Thank you. I didn't have to put it that high. Good. I have to write the definition. F of x minus g of x. What will you say? So by the way, can I create these functions? Do they exist? The sum, difference, and product? I don't know anything about ratio just yet, but do they exist? Why?
They're real numbers. They're numbers.
Because there is a common domain. Right? If one of them is defined on negative values and the other one is defined on positive values, it makes no sense to create any of them. Good. So then 6 minus 1 over x, and then? Good. So 6
Minus 1.
Negative 2 over x.
Indeed. So I take away an apple from you, and then I take another apple from you. So how many did I take from you? 2. Very good. Is it clear why the domain of this is that? But look here. It's not clear. Here. How come that the domain of the sum is this? Look at it. It's 6. 6 is defined everywhere. Yeah, but I have to think of how I created it. I created it with 6 minus 1 over x plus 1 over x. That's how I got to 6. That's why the domain has to be that, even if the function is 6. But I created it using two functions that are not defined at 0. Good. So is it clear why the domain of this is that? Yes? Yes? Good. So now the definition is f of x times g of x. In parentheses, 6 minus 1 over x multiplied by 1 over x. I have to distribute. Can anyone tell us what to write? Six over x, very good. I agree with 6 over x. Minus?
2 over x.
Careful. Now this is different. I'm not taking away an apple and then I'm taking away another apple. No. This time I have negative 1 over x times 1 over x. How do I multiply two fractions? Good. So the top is? And the bottom is? Yes, thank you very much. I don't have enough room here other than writing the definition f of x over g of x. Or maybe I do. Then 6 minus 1 over x over 1 over x. The question is if If what?
Denominator does not equal 0.
Correct. If 1 over x does not equal 0. When is a fraction 0? This is a fraction. In which
X
way?
equals 0.
When? No, that's undefined. When is a fraction 0? Not when the denominator is 0. We know that. When?
Numerator.
Yes. Is this numerator ever 0? No, it's never 0. So this is safe. Now here's what I would like to do. I would like to simplify this with this.
No, you can't.
Why?
That's exactly.
Because they're not factors. This is a factor, but 1 over x is not. Very good. You can leave it as is, or if you want to go further, I will keep the numerator after I find the least common denominator, which is, very good. What do I multiply the top of this fraction by? Very good. What do I have at the top?
6x minus x.
Minus
Minus
Oh,
1.
minus.
Perfect. How do I divide two fractions now?
multiplied by the reciprocal.
Yes, I copy the top and I, what do I simplify then? Very good. And the answer is? And you could say, but the domain of this, oops, it's out of. So the domain of this is earlier numbers. No, I cannot think in those terms. Have to make sure that when I divide these two fractions, they both exist. So that's why the domain is still negative infinity, 0, union 0 to infinity. Any questions? Any questions for me? Any questions? Yes, please.
And when we're doing this,
Yes?
it doesn't give you that option. It gives you yes to write negative infinity to infinity for the three first ones.
I have to see the functions. I have to see the
Because that's
functions.
all of the examples. And then the last one.
I have to see the functions. Give me a function. Or give me f and g. Any function.
4x plus
Yes. So f of x, 4x plus 5
plus
plus 9.
and then g of x is x plus x.
Good. What is the domain of f, please? Of course, polynomial functions. What is the domain of g? Very good. What is the common domain? And this will be the domain of which three functions always, forever?
Some
Very good.
negative
Different. Very good. Good. What are we asked to determine? Their domains and find the functions? Good. Very good. So let's do that. Perfect example. So f plus g. I have to write the definition. It's a lot of writing in this section. So f of x plus g of x. So I have 4x plus 9 plus x plus 7.
5x plus 16.
5x plus 16. Do we agree with f plus g? Very good. Now I need to determine the difference. Let's write f minus g of x equals f of x minus g of x. So f minus g of x, f of x minus g of x, which is 4x plus 9 minus parentheses x plus 7, or you make sure you distribute 4x plus 9 minus x minus 7, which is 3x plus 2. We are just combining like terms. Then fg of x equals f of x times g of x, which is
4x
4x plus 9 times x plus 7. I have to use FOIL here. I have no choice.
4x squared
4x squared indeed, plus
plus
Very good. 28x plus next plus 63. So 4x squared plus, is it 37x plus 63? We didn't do anything. We just distributed. It's just FOIL. We just multiply. Now the last function, f over g, this is by definition f of x over g of x. I copy f, 4x plus 9, I copy g, x plus 7. And if my MATLAB does not allow me to put that union, I will not be able to write the domain unless they only ask you what is. Right, but it has to be the union. So you're saying that it doesn't allow you to put the union?
Yeah,
Or?
the last one, yeah, but then.
But the functions were such in that the problem that we selected, they were such that they didn't have all real numbers as domains. We had to put the union for those because the functions were different. These are two linear functions. They will not have, in the sum, difference, and product, they will not have anything excluded. Yeah. So here we have that what?
Negative infinity.
Okay. So I have to write x plus 7 not equal 0 because that's how we find the domain of a rational function. I have to write x not equal negative 7, and now I can write the domain. Negative 7 union negative 7 to infinity. Yes, the previous two functions were way more sophisticated. They were not linear functions. Very good. There is a fifth method of finding new functions, and it's called function composition. Here's the notation. Not to be confused with the product. Or this. I will write down how we read this in a second. So the first one is called the composite of f and g. F comp g. The next one is, can anyone read the second one for us? Exactly. Comp f. And the last one, can anyone read it? Yes? Very good. F comp f. They are totally different. Any questions, Shannon? Go ahead.
So I was just wondering, what is that? Like, would that be my MATLAB? Like, that's just like a circle?
Yes, it's a circle.
Like right in the middle?
Yes, between f and g. Yes. Very good. So this is a totally different situation than the sum difference product ratio. Totally different. And in this particular case, we're not interested whether the two functions have a common domain or not. So I can create the function composition only if, and I'll explain in a moment, but there is no question about the common domain. They may or may not have a common domain. That is not the issue here. It is with the sum difference and product, but not with the function composition. Okay. First of all, let's explain what this means. By definition, and we have to write the definition always so we don't make a mistake, this is f of g of x. So this is the outer function. As you see, it's outside. And g is, what do you think? Of course. As you see, is right here inside, closest to x. So g is the inner, f is the outer. Okay, so let's say in this bubble I have x. What do I apply to x first? In other words, I'm asking, yes, I apply the inner function first. So let's say this is a number, 15. I will get here another number. But how do I write this? if this is x and I apply g to x, what should I write here? If this is 5 and I apply g to 5, then I will write g of 5. If I have x and I apply g to x, then I will write, that's it. As you see, it's right here. It's my starting point. It's the inside. It's a number now. To this number, I apply function g, the input, and this will be the output coming from g with particular x. To this number, now I apply, indeed. And what will I get? Exactly. So what is the problem that I may encounter here? Let's talk about it. Forget about this for a second. What does this set represent for G? Name. Thank you. What does this set represent for G? Name. Thank you. Range, correct? So this is the domain for G, and this is the range for G, correct? Okay, forget about this for a moment. What is this set for F? So it's domain, right? For F, this is the domain. And this is what for F? Perfect. So what has to happen here? Not common domain. The range of G must work well with the domain. Exactly. That's the problem here. I'm not going to ask you to, it's beyond the scope of this course, to find domain of function composition. I'm not going to do it. We do it in pre-calculus, but not here. So one more time. So what could go wrong? Just one sentence. What could go wrong? That this function brings here 5, for example, but I cannot apply f to 5. So the chain will be broken. So if the range of G does not work well with the domain of f, the function composition doesn't exist. So that's all I want you to remember. That's it. I'm not going to test you on finding domain of function composition. You may encounter problems in my math lab, but I will not put a problem in which I require you to find the domain of function composition. There is none. Good. That's good. Okay, so now let's look at a problem from... Yes, of course, any problem. F of x
equals 1 minus x. And here that is plus 3x plus 5.
Awesome. What are we asked to determine?
F of g.
We are asked to find f comp g of x. Perfect. G comp f. Very good.
F comp g comp 3.
Very good. Awesome.
G comp f.
Also 3. Perfect. Perfect example. You saved us time. We don't have to look in the book. I love that. Very good. So here's what I recommend. And this is not the only way. Once I have this function, how will I determine this?
Yes.
Plug in 3. And I have the answer to this part. Once I have this function, how do I determine this? Just plug in 3. Okay, so let's start with f comp g. Can anyone give us the definition of f comp g?